seem most suitable because, as you'll see, some of the themes touched by this project are very much about watersheds and water systems as political tools and geopolitical constructs. It's about the role of representation, visualizing and communicating and designing with complex ecological processes. And it also includes a series of considerations on how different types of visualizations have evolved historically in order to align with different scientific knowledge, political visions, actors, and geopolitical frameworks. This composite image of the Earth and its atmosphere brings together water vapor and particles, so dust, soot, mold, bacteria. And these are two fundamental components of my talk today. So what kind of a thing is a cloud? If the conditions are right, and if they find themselves in a stable, saturated parcel of air, aerosols can pull water vapor particles in, becoming nucleated cloud droplets. And when a congregation of droplets, a cloud, grows in volume, weight, and height until it reaches a moment when it becomes so heavy it can no longer hold on to itself, it makes its way back down towards the surface of the Earth as raindrops. Only to do this, and here what was once a cloud makes its way into vegetation, to bodies of water, surfaces the ground to transpire or to evaporate, to do it all over again and again and again. This is what we have come to know and name as either the hydrological cycle or the water cycle. And at any given moment, around 2/3 of our planet is covered by clouds. And these assemblies of microscopic droplets assist in the distribution of the sun's energy as storms push and pull from the equator out to the poles and back. We know that the same microscopic particles of dust and smoke and chemicals and other aerosols held by the gravitational pull of the Earth towards the surface of the planet are what seed and momentarily hold the clouds above. And it was American scientists researching aircraft icing for General Electric's research laboratories, Vincent Schaefer and Irving Langmuir, who claimed to be the first to succeed. Schaefer used, as you can see here, a deep freeze unit with various agents, using the air from his lungs, making a haze, followed by snowflakes. So he had, in essence, supercooled his breath into ice crystals. And soon after, his colleague, following on his success, Dr. Bernard Vonnegut, would discover the method and materials for cloud seeding that's most common today, the use of silver iodide. And then the first recorded attempt to modify natural clouds was in a flight in upstate New York in November of 1946, when silver iodide was discharged and snowfall was caused near Mount Greylock in western Massachusetts. In this NASA satellite image from 2008 of a dust storm new. Atmospheric rivers are currently considered extreme weather events. The most studied example of this kind is the Pineapple Express. It's an atmospheric river that originates near Hawaii and flows eastward as it follows the global ocean conveyor belt. And a long recorded history of observations has linked winter storms along the coast of the Western United States and Canada to this phenomenon, to the extent that an array of atmospheric river observatories have been installed between Southern California all the way up to the Canadian border as an early warning system to predict its landfall. a so-called picket fence of radars tuned in to detect the smallest variations in wind profiles and water vapor concentrations. And the concept of these atmospheric rivers dates back nearly 30 years when, back in 1992, a group of scientists from MIT and NASA proposed naming these filaments tropospheric rivers because they had the characteristics of rivers we know on land. They're places where water gathers to move in lengths many times their widths, and they persist for many days while being translated through the atmosphere. And their finding originated as a kind of fortuitous observation within their MAPS program, the measurement of air pollution, aimed at providing a near global map of the distribution of carbon monoxide in the lower atmosphere. The scientists were startled to find these thermal fingerprints of the air polluting molecule far away from any possible source of emission. And so, limited by the capabilities of this system that could not sense through the clouds, they turned to the total ozone, the TOMS, the total ozone mapping spectrometer, an instrument designed to return a more detailed portrait of the atmosphere by measuring the wavelengths of backscattered solar radiation. And it was through this reflectivity, this data provided by TOMS, that they saw moisture pathways emerge from the data, connecting the concentrations of carbon monoxide to their source regions. Water vapor, they were able to infer, was responsible for the transportation and the movement of carbon monoxide in the troposphere over long distances. And so just 2 years later, two of the paper's authors, Newell and Zhu, determined that these filamentary structures are responsible for the transport of almost all of the water vapor in the atmosphere, despite discharging only on average a third of the water they carry as either rain or snowfall. Which brings us to the current conceptual framework of water resources that we know, which is largely limited to water in rivers, lakes, underground aquifers, and other sources that can be used by humans directly, and does not normally include water that directly evaporates from land surface or transpires from vegetation. So we see in these classical representations the water cycle, conceived and drawn by Robert Holton, the American hydrologist and civil engineer, who established what is considered a modern Western understanding of the water cycle, how a particular idea of water's behavior is modeled after a northern temperate climate, and within a society oriented to the exploitation of natural resources for state-led industrial development. These historical and geographical circumstances, the one in which this diagram was created, do not necessarily correspond to the experience of water of most of the world's population. Nevertheless, categories such as green or blue water persist in contemporary hydrology, and we find them in the recent papers of a group of scientists and engineers from Tsinghua University. These different forms of water all exist and come into relation in the so-called critical zone, the heterogeneous near-surface environment in which complex interactions involving rock, soil, water, air, and living organisms regulate the natural habitat and determine the availability of life-sustaining resources on Earth. And it's scientists at the Tsinghua University, led by Wang Guanxian, who suggest that the accumulations of atmospheric water are actually topologies and that they have the potential to precipitate. They propose that they are made of a not yet named category of white water. Their papers, published between 2018 and 2019, define particular bodies and durations of water filaments, white water, as sky rivers, and they bring to us a new proposal, a new global system, a new way to study the water cycle. So while atmospheric rivers describe a phenomenon that physically exists and occurs, an event that occurs, the sky river is a kind of calculation. It's a constructed model, and it's explicitly devised for new forms of utilization and extraction of atmospheric water resources, the facilitation of its management, and potentially the establishment of claims of state ownership. The study of the sky river, it's argued, requires the establishment of a new discipline by its authors, one that develops theories and methods of expressing these atmosphere surface water resources that can meet the multi-timescale processes of surface runoff. It's the processes of precipitation and evaporation, these sort of discontinuities and topologies, where those who study and name the Sky River believe that these possibilities can be found, these red lines that almost appear to crack the earth into pieces. In the visualizations and the papers, the Sky Rivers here are shown as a system of pathways. The hard lines of the Sky Rivers establish what they believe is a long-term knowledge of recurrence, something that can be wired to an infrastructure for extraction. So the Sky River is a model, but there's also the Sky River Project, and this is located at the convergence of one of these pathways above the Tibet Plateau. It's called the Water Tower of the World for it is the source of most of Asia's significant rivers. The plateau provides water for more than 2 billion people. And on the plateau is an area called the Source of Three Rivers, and it drains out and into the Yangtze, the Yellow, and Mekong rivers. And here in the troposphere above is where a particular confluence of water vapor channels, the so-called sky rivers, have been identified. And here's where scientists believe the rivers of the earth meet the rivers of the sky. Broadly speaking, the Sky River Project is meant to intercept incoming water vapor carried by the Indian monsoon over the Tibet Plateau by using cloud seeding technology to modify the spatiotemporal distribution of precipitation above the pilot region to make it rain. The distribution of water vapor, the so-called white water, can be seen here above the Tibet Plateau. And while previous research on atmospheric rivers was focused on the transportation of water vapor and its short-term manifestation in extreme weather events, the attention of Guanxian and his colleagues is on the long-term reconfiguration of infrastructure of atmospheric rivers so that they may be fully brought into the water resource management systems on land. And here's the test site as well. This is not a new desire and not a new project per se. Weather modification operating stations have long been installed across China to increase precipitation and elsewhere. Here are some screen captures from municipalities using cloud seeding that's been found on the internet. But it's the cloud seeding stove that is a discrete object built, replicated, and placed throughout the Tibetan Plateau, which is where and how the physical embodiment of the Sky River, both as a phenomena and as a project, is seen for the first time. Installed on mountaintops in strategic positions, they're exposed to upward winds that theoretically carry their exhausts into cloud formations above to trigger rain. Decorative elements appear on almost all of the stove's exteriors, while the interior houses military rocket engine technology. So the stove is a ground-based silver iodide generator, so a cloud seeder. And this is also some of the plans that we were able to find readily available on the internet. By 2018, more than 500 of these stoves, solar powered with the capability to be operated remotely through a satellite forecasting system, were installed on the alpine slopes of Tibet and other areas for experimental use. The Sky River Project is ultimately a ground network of tens of thousands of stoves planned for deployment across the plateau, making it the world's largest and most ambitious cloud seeding experiment to date. The sprawling ground network will be met in the sky by a network of satellites and radar. This digital layer is developed by the state-owned China Aerospace Science and Technology Corporation, and it monitors global water vapor data, guiding the operation of the stoves, telling them when to fire, when to be turned off, and through these communications, making them all part of a new atmospheric terrestrial infrastructure. But these sky rivers emerged from a history of water management that dates back thousands of years to the establishment of the Xia dynasty and its founding sage king Yu the Great, and his flood-based recreation myth, wherein Yu established, quote, the proper order of the mountains and the waters by opening passages in the mountains and guiding rivers into their courses, allowing, they say, the waters to flow naturally. The cloud logo that you see on the right of the Chinese Meteorological Administration, which is found on almost all of the exteriors of the stoves on the left, carry forward the language of the of the Dunhuang star atlas of the 8th century, seen here. Historian of ancient China, Mark Lewis, writes too that it's not a coincidence that the root of the Chinese character to govern is water. The very lines and mountains and rivers that you traced out, he writes, are those that divided China into the 9 provinces. And it's this powerful mythology of the flood that has provided a background for accounts of the structure of the world, along with the forces that made that structure possible. The story of you is the story of world making, and it's also the story of infrastructure. According to Lewis and others, it offers us, quote, a mythology of contemporary practices of water control in both its literal and figurative use of demarcation, of division, and of expulsion to achieve the desired hydraulic stability of the Yellow River and flood control in the North China Plain. The modern geographical imaginary of the country is tethered to a rigid conception of water balance, where a scarcely populated, water-rich south is often placed in opposition to a densely inhabited and agriculturally developed but water-scarce north. Today, China is facing increasingly severe water scarcity due to uneven spatial distribution of water resources across the 9 major river basins of the national territory. And these disparities are reinforced by spatial-temporal patterns of precipitation, and they're exacerbated by a mismatch between local socioeconomic needs for water. The result is that there's a limited overall amount of water resources with extremely low water availability on a per capita basis in many areas to the north of the Yellow River, which we can see here in a map of the water stress index. While the majority of China's irrigated farmland is in the north, its products mostly feed the heavy populated cities of the south, where wealthier dietary preferences demand water-intensive crops alongside a spiking increase in meat consumption. So as water moves northward through rivers, pushed through aqueducts and canals, pumped from aquifers to irrigate exhausted northern farmlands threatened by desertification, it also circles back south inside food. Water may flow in the atmosphere, above and below the ground, but it also flows through economies. The river, if we can think of here, is not a single stream, but many streams that flow through bodies and territories. China's South-North Water Transfer Project is a multi-decade mega infrastructure project that has aimed to transfer water from the Yangtze River Basin to the Yellow River Basin. The goal has been to move almost 45 billion cubic meters of water across the country every year. But the project has laid bare an unsettling reality that these traditional, even if extraordinary, water management techniques deployed on this national scale have reached their upper limits. And to find new water resources and to develop the techniques to manage them has become a national priority concerning both national water security and national security. Wang Guangjian, the head scientist of the Sky River Project, was working on the Tibet Plateau when, as the story goes, he noted that the clouds were different. The clouds, he said in an interview, seemed to be pressing down against the riverbed. And in that moment of seeing the clouds meet the ground, he recalled the words of Chinese poet Li Bai from the poem An Invitation to Wine, a poem so popular and so deeply saturated in Chinese culture that almost all school children know the phrase, quote, "Do you not see the yellow river come from the sky?" If the topology of water is imagined as a continuous surface, then water flows into the plateau from sky rivers and out of the plateau through rivers on the ground. Water vapor is not then a stable feature of planetary origin, but of the atmosphere. Its fundamental composition and materiality challenge us to overcome our familiar principles of direct Cartesian verticality when conceptualizing borders and boundaries. Projecting the topology of the watershed up and into the sky with the wind, with temperature and pressure as vectors, this allows a kind of vertical appropriation to take hold and principles of terrestrial sovereignty possibly extended up and into the atmosphere. If new lines on the land are drawn by changing the geography of the sky in the form of displaced rainfall, of fortified glaciers, of floods, or chemical alteration of the water-bearing stratum above, Then faced with the new concept of atmospheric water resources and a new definition of the water that circulates in the atmosphere, water vapor is converted. It's reimagined from a natural occurrence into a possible asset that can be secured through state infrastructure. The Sky River, however, the model, not the project, whether one may agree with it or not, is a powerful if paradigmatic act of geographical reimagination. In this conceptual leap, atmospheric water and conventional surface water are brought together in a kind of long-term coupling that follows the way water gathers and flows in terrestrial rivers. And it offers up new collective political imaginaries that don't operate solely in the favor and ambitions of the nation state. Because even though in the imagining of a new theoretical framework for the hydrological cycle, there emerges the Sky River Project, the simultaneous expansion of the domain of resource extraction to the atmosphere, there is also its parallel, not yet in existence, where the same imagination can be retooled for non-nation state ambitions, as in the face of climate change and crisis, we seek out new possibilities for stewardship, for governance, for economics, of ecologies, of geopolitical frameworks. So this is, some preliminary research, and it will continue examining established and emerging, successful and not so successful plans to govern waters, including large-scale weather modification proposals like the Sky River, as a means by which to interrogate and propose different agile, responsive configurations of the role of design as we continue to move forward together in times of uncertainty. Thank you.